Does the universe play by its own rules? That might sound like a question for a philosophy class, but I'm talking about black holes. Specifically, one of physics's biggest unsolved problems, the black hole information paradox. Black holes are weird. They're places where gravity is so strong, not even light can escape. Once something crosses a black hole's event horizon, it's gone forever, or seemingly so. But what if a black hole consumes more than just matter? What if it consumes information itself? That's the black hole information paradox. Our story begins with a star. When a big star dies, its core can collapse into an infinitely dense point called a singularity. All the star's matter gets squeezed into a space smaller than a proton. Then gravity takes over. It pulls everything inward with an inescapable force. The boundary of this region is the event horizon. Once anything crosses this boundary, it can never come back out. Not even light. That's why black holes are black. Nothing can escape their grasp, not even information. But here's the problem. According to physics, information can never be destroyed. Yet, if a black hole completely swallows something, physics says it should spit it out, at least some of it. Like a cosmic recycling bin. This would make sense if black holes were like cosmic vacuum cleaners, just gobbling up everything in sight. But that's not how they work. In the 1970s, Stephen Hawking made a shocking discovery. Black holes aren't entirely black. They emit a faint radiation now called Hawking radiation. Basically, empty space has a tiny amount of random energy. Sometimes this energy creates particle and T-particle pairs. Usually, these pairs quickly annihilate each other. But near a black hole, one particle can fall in while the other escapes. This makes black holes more like leaky faucets than vacuum cleaners. Over time, they lose mass and they get smaller and smaller until, kaboom, they evaporate completely. If a black hole evaporates, what happens to the information it swallowed? Some physicists say the information escapes in the radiation, but no one has ever detected any signal from a black hole that could contain information about what fell in. Other physicists say the information is stored on the surface of the black hole, like a cosmic hologram. But holograms require extra dimensions, something we have never seen. So, the black hole information paradox remains a mystery. How does physics resolve the conflict between black holes? Destroying information and physics' fundamental rule that information can never be destroyed. Well, there are many ideas. One is the holographic principle, which says that all the information in a region of space is stored on its boundary. Another idea is that firewalls at the event horizon reflect and amplify radiation, creating a wall of light that destroys anything that tries to cross. Still, others propose that black holes are connected by wormholes, which could spread information across the universe. But one thing's for sure. Solving the black hole information paradox will require a revolution in physics. Perhaps something deeper than Einstein's theories of special and general relativity. Could there be a more fundamental law of physics that we don't know? Something that resolves the paradox without the need for extra dimensions or wormholes? Or are we missing something else entirely? The black hole information paradox isn't just about stars. It's about whether the universe plays fair with its own rules. Does information ever die? Or does the universe hide its secrets where we can never look? We may never know for sure. But the search for answers is just beginning. Now, you'll never understand quantum mechanics by watching another YouTube video. You need to experience it.